Hello everyone, welcome back to Infinity Physics. In the last lecture we had a discussion about Cartesian sign conventions for spherical mirrors, and these Cartesian sign conventions are very helpful in derivation of the mirror equation and also in the understanding. Remember, the derivation will not be asked in your exam because in your NCERT book only the equation is given. The equation is given directly, there is no derivation, right? So if you want to understand the derivation, you can watch the full video or you can solve the numericals from the next video. You can understand how to use this formula. Right, in this video I will guide you how to derive this mirror equation. So with the definition, the formula which gives the relation between object distance u, image distance v and the focal length f is known as mirror formula. So here the object distance, that is the distance of the object from the pole. So this distance, right, is u. Image distance, the distance of the image from the pole, is called v, and the focal length of the mirror. So the formula which gives relation between all these three quantities is known as mirror formula. So here f is the focal length, u is the object distance and v is the image distance, and this relation, this equations give the relation between all these three quantity of mirror, and hence it is called a mirror formula. So as shown in figure, the object or AB of height h is placed at a distance u. So this is the distance u, this distance, right? So this distance from the pole to this point B is the object distance in front of a concave mirror of small aperture. So this is our aperture, and just beyond the center of curvature. So this is the center of curvature, and object is placed beyond the center of curvature. Therefore its real, inverted and diminished image B dash A of height h dash is formed at a distance v from in front of the mirror. So here is the image of the object, and how it is obtained? It is obtained using the simple rules that we have discussed in the case of concave mirror. So here this is our object. A is the head of the object and B is the tail of the object. So rule number 1, when the ray is parallel, after reflection it passes through the focus. Rule number 2, when the ray is passing from the focus, it goes parallel. First rule, parallel, focus. Second rule, from the focus goes parallel, right? Third rule, whenever the ray is on the pole at some angle, let's assume that angle is theta or angle 30, let's assume that it will be easy. So if this angle is 30, then it will reflect with the same angle 30, right? And rule number 4, when the ray passing from the center of curvature, after reflection it traces back the same path. See, all these four rays are meeting at this point. From the head these rays are coming, so here we will obtain head. So we have obtained the image between C and F. This is the case number 2 of a concave mirror, and the image obtained is real and inverted because it is obtained on the left of the mirror. So if we place a screen here, we can obtain it on the screen. So it is real and inverted, and also it is diminished, that is compared to the size of the object it is smaller. Now you have to consider some triangles here. See here, first triangle AB and C, right? This is triangle ABP, this triangle, right? And another triangle, similar triangle we have to find, then it is A dash B dash P, this triangle. And how it is similar? See, this is 90 degree, this is also 90 degree, and here if you see this angle and this angle, these two angles are same. So in this triangle and in this triangle, two angles are same, this angle and this angle. If these two angles are same, then ultimately the remaining angles are also same. So we can say this, these triangles are similar, right? The ratio of their that is, if you see the Taj Mahal, right, then it's mini version, this is a scaled down version. So both are similar but their sizes are different. So we can say this triangle ABP and A dash B dash P are similar. So if you know the theorem of similar triangles, then if we take the ratio, right, if we take the ratio of these two triangles, it will be similar. We will see in the next slide. So here, from the Cartesian sign convention, right? Please watch the previous video. If you don't know the Cartesian sign convention, you will not understand this. So here, object distance PB, this distance is the object distance, and we have assumed that this distance is u, right? So here this distance is u, but it is lying on the left of the mirror, so it is minus u. Similarly, this distance PB dash is lying left of the mirror, and this is our image. So this distance PB dash is the image distance, so it is minus v, and this distance is the focal length, right? Here PF, it is lying on the left, so it is minus f, and center of curvature of concave mirror lies outside the mirror. So here PC, this distance is the radius of curvature, and it is minus r. Now it is clear from the geometry of the figure that the triangle, right angle triangle ABP and A dash B dash P are similar. That is this triangle that we have discussed. The triangle ABP and triangle A dash B dash P. Now let's see how to equate them. So here the simple picture is given, right? This triangle ABP and A dash B dash P. So from the similarity of triangle, from that theorem, we can take the ratio of these two sides, that is A dash B dash P, this is A dash B dash P, is equals to PB dash by PB. So both the ratios are equal because these triangles are similar. So if we take the ratio of these sides, then the ratio will be same. So A dash B dash by AB is equals to PB dash by PB. Now from the Cartesian sign convention, we have obtained that PB is equals to minus u and PB dash is equals to minus v. So that we will put in that equation. So PB dash is equals to minus v and PB is equals to minus u. Minus minus plus. So we get our first equation, that is A dash B dash by AB is equals to v by u. This is our equation 1. Similarly, in triangle ABC and A dash B dash C are similar. These two triangles are also similar. See, you can also find from the figure also. See here, where you can find here ABC, this triangle, right? And this triangle A dash B dash C. So these two triangles are same. Why? See, this is 90 degree and this is also 90 degree, right? You can observe it here. This is 90 degree. And these two angles are opposite. So if two angles are same from a triangle, then third angle is also same. So we can say this is the scaled down. This is a smaller version of this triangle. So these two triangles are similar. So again we can use the theorem of similarity of triangles. So we can take the ratio of the two sides and equate them. So here again A dash B dash by AB, A dash B dash by AB is equals to B dash C by BC, right? So we can or CB dash by CB, we can take the ratio. So this is our equation number 2. Now from the figure you can easily understand. See here C dash. So where it is here CB dash. Now if I take the whole length, I want this, right? So of this part is PB and I want only, sorry, the total length is PC, right? But I want only CB dash. So PC minus, means this is PC. If from the PC I subtract this PB dash, so PB dash, so this total PC minus this, so I will get 1, this line I will get, right? So PC is equals to minus R, you can check back in the previous slide, right? And PB dash is the minus U. So I can write here CB dash, means this CB dash is equals to PC minus PB dash, right? So I will get this particular line. So it is PB dash. So PC is minus R minus PB dash is minus V. So minus minus plus. So I will get minus R plus V. Similarly, you can also obtain CB. So here CB. So here this length is PB. So PB minus, if I subtract this particular part, right, PB, this from total part, PB minus PC, then I will get this length. See, observe it here. See, PB minus PC. I am subtracting this part, so I will get this CB. So PB minus PC is equals to, I can write CB. Now PB is minus U minus PC is R, but minus R, so minus minus plus. So here we get CB dash is equals to minus R plus V divided by CB is equals to minus U plus R. Now we will put this thing, that is CB dash, in this equation here, and minus U plus R, that is equals to CB here. So we will get our equation number 3. So see here, AB. So you can see here A dash B dash by AB, A dash B dash by AB is equals to minus R plus V by minus U plus V. Instead of CB dash and CB, we can put these two terms, right? So this is our equation number 3. Now if you see the equation number 1, what was the equation number 1? A dash B dash by AB is equals to V by U, right? And here A dash B dash by AB is equals to minus R plus V by minus U plus R. So again we can equate this because their LHS are same. So when left hand side's equation is same, then the right hand side equation is also same. So here we can equate V by U is equals to minus R plus V divided by minus U plus R. So we will equate this and obtain the new equation. So here we have equated, right? You can find it here. So here we have equated that. Now by cross multiplying, that is, if we take this term, right, this particular term to the right side, left side, and this U to the right side, then we will get here V into minus U plus R is equals to U into minus R plus V. So by doing this, obtain that here V into minus U, so minus UV, V into R is equals to plus RV is equals to here minus R into U plus V into U. So by doing this, we obtain this equation. Now just rearrange. We will take these two terms which are negative, right? We will take this term this side, and this sign here, see, it is minus UV, we can take this side, so it becomes plus. So here we have VU, and when these negative terms come this side, it again gets added, so it is UV. So UV or VU, it is same, so we can write it is 2UV. So here we have obtained that RV plus it is coming this side, so it is plus RU. So plus RV plus RU is equals to 2UV. Now R is common from these two terms, so it is V plus U is equals to 2UV. Now we will divide this total equation by RUV. So if we divide it, we will get here R get cancelled, so we will get V plus U by UV is equals to here UV get cancelled. Why? Because we are dividing with RUV. So we will remain with 2 by R. Now if you again solve this equation, right, if you solve this equation, you will get this equation, that is 1 by V plus 1 by U is equals to 2 by R. You can solve it by yourself, right? It is very easy. Now when the object is placed at infinity, if we place the object at infinity, that is at a very large distance, so in that case our object distance, that is u, is equals to infinity. So for the cases whenever the object is at infinity, we get the image at focus, right? So here we can write u is equals to, in this equation we can write u is equals to infinity, and v, that is the object distance, is equals to f. So here we have put v is equals to f. So in this equation, if we put these two terms, so here v is equals to 1 by f and here u is equals to infinity, so is equals to 2 by r. Now 1 by infinity is equals to 0. So what you will get here? What you will get? See, f is equals to r by 2. What we have done here? Nothing. We have just put these two values in this equation, right? So by putting this, we get f is to r by 2. Now again we can use this f is equals to r by 2, that is r by 2 is equals to f. So here we have 2 by r, right? So we can put this value in this equation again and we can obtain our mirror formula. So here you can see that 1 by v u plus 1 by v is equals to 1 by f. How? Here r was there, right? So we have obtained that f is equals to r by 2. So 1 by f is equals to 2 by r, right? We take the reciprocal. So here 2 by r was there in the last equation. Here you can observe that here 2 by r was there. So here instead of 2 by r we can write 1 by f. So we have done this thing. We have put here the value of 2 by r and we have obtained our final equation, that is f is 1 by v or 1 by u plus 1 by v is equals to 1 by f. Remember, this mirror formula is true for both type of mirror, that is concave or convex. Or we have also obtained another relation, that is f is equals to r by 2 for spherical mirrors, or you can also say r is equals to 2f. Now here I am having a question for you. What is the focal length of a plane mirror? That is, this is a plane mirror. What is its focal length? 0, f is equals to r by 2, infinite, 1, or none of the above. Comment your answer and please provide the feedback. You liked my lecture, then please share and subscribe. Have a nice day. And don't forget to comment your answer in the feedback.